Hey guys, how's it going? I boosted the PushbackInputStream. As you are an experienced Java programmer, you certainly know what PushbackInputStream is good for, but just for those not so experienced with that class, a PushbackInputStream simply works like this. It wraps another input stream, and whenever you pull information from the PushbackInputStream, you actually get information from the wrapped input stream. But you can push information into a PushbackInputStream. Yes, it's actually writable. So if you push information into the PushbackInputStream, the next read from the PushbackInputStream will read this pushed information first. What is this good for? For example, you could use a PushbackInputStream if you want to read the magic byte of a file to find out about a file type. So what you do is you use the PushbackStream wrapping the file stream, read the first byte, which is the magic byte, then push it back into the PushbackInputStream so it stays in a buffer inside of the PushbackInputStream, and then you simply go with transferTo to transfer the complete image to, I don't know, any kind of image processing. As you are watching my YouTube channel about Java programming and in particular Java performance optimizations of OpenJDK carefully, then you already know what I did to BufferedInputStream and to InputStream when it comes to calling transferTo. In today's video, I will show you what I contributed to OpenJDK's Java source code in version 20 when it comes to the implementation of the PushbackInputStream transferTo method in Java, which is roughly the same I did already to the BufferedInputStream. You can find this in this video. The PushbackInputStream is really tightly related to the BufferedInputStream, so it was quite simple to introduce this new performance optimization to the Java source code of OpenJDK 20 after I contributed a similar optimization already. So please don't mind that I go into all the details of this new contribution, in particular the details of the unit test. In this contribution, what I did is simply that I implemented the transferTo method. There was no implementation of transferTo before for PushbackInputStream, so the original implementation chimed in, which is rather slow because it pulls all the bytes from the original stream into the memory of the JVM and then pushes it from the memory of the JVM to the output stream. Just as with my BufferedInputStream optimization, I will try to perform the same without. This is what we will do here. As you can see here, I am calling the InputStream's transferTo method, which allows the operating system to not forward the information to the JVM at all, but directly to the output stream. For example, if you're copying information from file to file, then the operating system will do that much faster than the JVM could, and you can leave out a lot of CPU cycles by doing that. So what do I have to do here? The first thing is I need to be sure that I'm actually in the PushbackInputStream class itself, but not into a descendant class. This is because the descendant class might rely on the original implementation, which was calling the read method, and I will not call the read method, so possibly I would break something in all the descendants. As we have to stay backwards compatible in all cases, we have to do this check, so we're safe. We are only changing our own behavior and not the behavior of any subclasses. As you can see here, I'm again checking how much information is in the pushback's buffer, which is buff, and the length is the length of the buffer, and pos is where I am in the buffer. So if this is 0, then there's nothing information in the buffer, and we can directly call the optimized transferTo method of the input stream. So we offload to the operating system here. But in case there is something in the buffer, then we have to push that down the stream. So we're going here with outright. And again, as I already explained in an earlier video, we have to be safe to not allow poisoning the buffer, which means an evil output stream could write into this buffer. And we must not allow an evil output stream to read information from our buffer outside of this range, because we only want to provide information in this range, and it might be a secret or something. So it's always a good thing to carefully wrap your information with array's copy of range, which provides a new array basing on this information from this position to that position exclusively. So we have a temporary buffer here, provide that to the evil output stream. The evil output stream puts this poisoned information in the buffer, but we are throwing away the buffer, or the output input stream tries to read beyond buffer length or prior to pos, which is not possible because the buffer is smaller, so he would end up with an exception. So we are safe from poisoning and leaking and can safely provide this temporary buffer, then set pos to length, which indicates to PushbackInputStream that the buffer now is completely used. There is nothing more to read from that buffer anymore. And then we're done. The test of the PushbackInputStream is mostly the same as the test for the BufferedInputStream. So let's concentrate on the difference. The difference solely is that we have to simulate a pushback operation. So here you can see if we are testing a PushbackInputStream, then we are creating an array of an arbitrary length, and we read information into that array, for example, the magic byte or the file header. And then we do an unread operation. It's not nice that this is called unread. Actually, it's a push information. It's a push operation. We could also push bytes we never read before, but this is what the stream was made for originally. So it's called unread. So we're pushing back the same bytes. So this is the sole difference to the BufferedInputStream, because the BufferedInputStream does not have an unread method. As I know, a lot of Java applications are using the PushbackInputStream, and even more are using the BufferedInputStream, because everybody who has to deal with magic bytes or file headers needs these tricks, and everybody who cares about performance learned to use the BufferedInputStream before. So with the two code changes I did to the OpenJDK Java source code, these two kind of applications will be definitively faster in future, at least if you're working with files. Thanks for watching this video. Please give me a thumbs up, subscribe to my channel, stay safe, and as always, party on.